Section 8.2.2 of the National Fire Protection Association 1033 Code Book addresses tailing out requirements. This section is crucial for understanding the standards and procedures related to ensuring electrical safety during fire investigations. Tailing out refers to the process of removing or disconnecting electrical conductors, particularly after a fire, to prevent further hazards and facilitate a thorough investigation. The NFPA 1033 standard provides the minimum requirements for professional qualifications for fire investigators. This standard is used by authorities having jurisdiction, or OJs, to determine if an individual is qualified to conduct fire investigations. Tailing out procedures involve several key considerations. Firstly, it is essential to identify the source of electrical power and ensure that it is properly disconnected and de-energized before commencing any work. This may involve locating the main electrical panel, identifying the relevant circuit breakers or fuses, and switching them off. Secondly, proper personal protective equipment, or PPE, must be worn at all times during tailing out operations. This includes items such as insulated gloves, safety glasses, and appropriate clothing to protect against potential electrical hazards. Thirdly, a thorough inspection of the electrical system should be conducted to identify any damaged or compromised wiring, components, or equipment. This may involve using testing equipment such as multimeters or voltage testers to verify that circuits are de-energized and safe to handle. Fourthly, careful documentation of the tailing out process is essential. This includes recording the date, time, location, and specific actions taken, as well as any relevant observations or findings. This documentation can be valuable for future reference and for legal or insurance purposes. Fifthly, when tailing out electrical conductors, it is important to use appropriate tools and techniques to ensure a clean and safe disconnection. This may involve cutting or disconnecting wires, removing connectors, or capping off exposed ends to prevent accidental contact or short circuits. Sixthly, any damaged or compromised electrical components or equipment should be properly labeled and tagged to prevent their reuse or re-energization. This helps to ensure that the electrical system remains safe and compliant with applicable codes and standards. Seventhly, after tailing out is complete, it is important to conduct a final inspection to verify that all electrical hazards have been addressed and that the area is safe for further investigation or reconstruction. This may involve using testing equipment to confirm that circuits are de-energized and that there are no potential shock hazards. Eighthly, it is important to be aware of any specific local codes or regulations that may apply to tailing out operations. These codes may specify additional requirements or procedures that must be followed to ensure compliance. Ninthly, training and certification in electrical safety and tailing out procedures are essential for individuals who perform these tasks. This training should cover topics such as electrical hazards, PPE, testing equipment, and safe work practices. Tenthly, collaboration with other professionals such as electricians or electrical engineers may be necessary in certain situations. These professionals can provide specialized expertise and guidance to ensure that tailing out operations are conducted safely and effectively. Furthermore, it is crucial to understand the potential hazards associated with tailing out electrical systems. Electrical shock is a significant risk, and even low voltages can be dangerous. Burns are another potential hazard, which can occur from direct contact with energized conductors or from arc flashes. Falls can also be a risk, particularly if tailing out operations are performed at heights or in confined spaces. In addition, it is important to be aware of the potential for exposure to hazardous materials such as asbestos or lead, which may be present in older electrical systems. Finally, it is essential to follow all applicable safety procedures and guidelines to minimize the risk of accidents or injuries during tailing out operations. Tailing out procedures must be conducted in a manner consistent with the National Electrical Code, or NEC, and any other applicable standards. The NEC provides detailed requirements for electrical installations and safety, and it is essential to comply with these requirements to ensure the safety of people and property. For example, the NEC specifies requirements for grounding and bonding of electrical systems, which are critical for preventing electrical shock hazards. It also provides requirements for overcurrent protection, such as circuit breakers and fuses, which are designed to protect electrical circuits from damage caused by excessive current flow. In addition, the NEC addresses the installation and use of electrical equipment in hazardous locations, such as areas where flammable gases or vapors may be present. The NFPA 1033 standard also emphasizes the importance of continuing education and professional development for fire investigators. This includes staying up to date on the latest codes, standards, and best practices related to electrical safety and tailing out procedures. By continually expanding their knowledge and skills, fire investigators can ensure that they are well equipped to handle the challenges of conducting fire investigations safely and effectively. Moreover, it is important to recognize that tailing out procedures may vary depending on the specific circumstances of a fire investigation. For example, the extent of damage to the electrical system, the presence of hazardous materials, and the accessibility of the site may all influence the approach that is taken. In some cases, it may be necessary to involve specialized contractors or consultants to assist with the tailing out process. These professionals may have expertise in areas such as electrical engineering, hazardous materials remediation, or structural engineering. Ultimately, the goal of tailing out operations is to ensure that the electrical system is safe and that the fire investigation can proceed without further risk of electrical hazards. By following the guidelines and procedures outlined in the NFPA 1033 standard and other applicable codes and standards, fire investigators can minimize the risk of accidents or injuries and ensure that their work is conducted in a safe and professional manner. Understanding the role of electrical systems in fire incidents is also crucial. Electrical malfunctions can be a primary cause of fires, and the investigation should aim to determine if faulty wiring, overloaded circuits, or defective equipment played a role. The investigator needs to be able to identify the point of origin and the cause of the fire, and electrical evidence can be critical in making this determination. Furthermore, the investigator should document all relevant observations, including the condition of the electrical system, the presence of any unusual odors or sounds, and the location of any electrical components. This information can be used to reconstruct the events leading up to the fire and to determine the cause. In addition to the technical aspects of tailing out, it is also important to consider the legal and ethical implications. Fire investigators have a responsibility to conduct their investigations in a fair and impartial manner and to avoid any conflicts of interest. They must also protect the privacy of individuals and businesses and to maintain the confidentiality of any sensitive information that they obtain during their investigations. In addition, fire investigators should be aware of the potential for civil and criminal liability. They may be held liable for damages if their negligence or misconduct contributes to a fire or if they violate any applicable laws or regulations. Therefore, it is essential to conduct fire investigations in a careful and thorough manner and to seek legal advice if necessary. The proper management of electrical evidence is also a critical aspect of fire investigations. Electrical components that are removed from the fire scene should be carefully labeled and stored to preserve their evidentiary value. The investigator should also document the chain of custody for all electrical evidence to ensure that it is admissible in court. In some cases, it may be necessary to submit electrical evidence to a laboratory for further analysis. A qualified electrical engineer or forensic scientist can examine the evidence to determine the cause of the electrical failure and to assess its contribution to the fire. Moreover, the investigator must be aware of the potential for spoliation of evidence. Spoliation refers to the destruction or alteration of evidence that may be relevant to a legal proceeding. If electrical evidence is spoliated, it may be difficult or impossible to determine the cause of the fire, and the investigator may be subject to legal sanctions. Therefore, it is essential to take steps to protect electrical evidence from damage or destruction and to maintain a complete and accurate record of all actions taken. Finally, it is important to communicate the findings of the fire investigation to all interested parties, including the property owner, the insurance company, and the authorities having jurisdiction. The investigator should prepare a written report that summarizes the results of the investigation and provides recommendations for preventing future fires. The report should be clear, concise, and objective, and it should be supported by credible evidence. In conclusion, tailing out procedures in accordance with NFPA 1033, Section 8.2.2 are crucial for ensuring electrical safety during fire investigations, requiring a thorough understanding of electrical hazards, proper use of PPE, careful documentation, and adherence to applicable codes and standards.